Sounds like we are good. Cool. So, for those of you that don't know me, my name's Anthony. I'm the Director of IT here at Oak Hill Collaborative, and what we're going to be talking about today is 3D printing. We were supposed to do this last week for Digital Inclusion Week. However, if you were awake during the day and use Facebook often, you'll know that it went down for about 6 hours, the great outage of 2021. So, we held the Digital Inclusion Week talk here in person, and it was a great turnout. People got to play with the 3D printers, design their own 3D models, and learn about all the different types of 3D printing. Unfortunately, we did not get to record any of that and live stream any of that because Facebook was down. So we decided to take time today to go ahead and redo it just for the virtual audience. So if you're watching this, you'll be getting relatively close to the same experience that you would have gotten if you had tuned in Monday. The only difference is that I'm not going to be showing you the 3D design software and how to get that software from 3D model to 3D print. The reasoning for that is because it involves me moving around the camera quite a bit, and with the technical difficulties we've already experienced, I don't want to risk anything else. So, if you would like to get more hands on experience with 3D printing, there will be my email at the end of the presentation. You can reach out, set up an appointment, get a tour of our facilities here at Oak Hill Collaborative, and I'll be able to show you the 3D design software that we use here, how to 3D print, and you'll be able to go home with whatever you wanted to print. So I'm going to give it just a couple more minutes before we begin. I want to make sure that everything's well on my end as it is on yours, and then I will flip the screen over to the presentation and we'll get started. Goodness. All right, so without further ado, if you're tuning in right now, this is a redo of the Digital Inclusion Week 2021 Day 1 talk. Here at the Collaborative, we held a talk in person about 3D printing, additive manufacturing, and how you can use it. And during that time, we were unable to stream. We're able to stream now, so for the virtual audience that couldn't tune in last week, now's your chance. Without further ado, I'm going to start talking about 3D printing. All right. So, as you know, my name's Anthony, and if you've been down here, you've probably seen me working on a computer, a printer, or whatever. As I keep the lights on and the computer's happy, I'm also the person to get a hold of if you'd like to come down to the 3D printing lab, which is actually where we're at right now with all these nice 3D printers. Actually, I had to turn one of them off, right, because they were printing and being real noisy. Can't have that during a talk, but um, and today's talk is going to be about introduction to 3D printing. Just to real quickly go over all the topics we're going to be touching upon here today. What is 3D printing for those that aren't sure, where it came from, what you use it for? We're going to touch very briefly on the history of 3D printing because it's a very new technology. There's not a whole lot of history behind it, but still feels important to cover. Uh, I've kind of broken down 3D printing into four distinct steps. By all means, I'm not the authority on 3D printing, but I feel like these four steps will happen no matter which type of printer you're working with. There's also going to be a quick discussion on consumer versus industrial printing, as a lot of people know that the difference is price. Industrial is going to be more expensive, but what we're going to talk about is why is it more expensive. We are going to go over 5 different types of 3D printing and how they're used in the industry. And the hands on session, sadly, is just for those who were able to make it to the in person part of this hybrid presentation last week. But as I mentioned earlier, in the last slide, I'll have my contact information and you should be able to email me to set up an appointment. And of course, you're able to ask me any questions that you may have about 3D printing, either here in the Facebook Live chat, or you can send them to me if you're watching this archived later. So let's talk about what is 3D printing. Let's get the elephant out of the room. Just real quick, it is the digital fabrication of prototype materials, which is a bunch of fancy words for toothpaste through a tube, or at least I think that is the easiest way to understand it. Imagine a computer controlled glue gun that is able to make sharp turns, sharp angles, shoot out glue in a curve, layer by layer by layer by layer. And once it gets to the top layer, you should have a finished 3D model. The computer controlled element is typically a simple microcontroller in which it will read off a list of instructions that tells its motors exactly where to put the print head on the bed and how much to deposit at what speed. It's very monotonous, which is why we don't do it ourselves. We have the computer do it. We just tell it what to do. 3D printing is unique compared to other manufacturing methods in that it has a very large range of materials. Some molding methods may only be meant for silicone or for a certain kind of metal. 3D printers, assuming that they are configured correctly, can hit the right temperatures, so on and so forth, can print multiple materials. They have a unique economy of scale, which simply means that there's a larger output cost than there is an upfront cost. For consumers, 3D printers can be got for relatively cheap, but their expenses will add up as time goes on as you print more and more things. So the history of 3D printing, for those curious, it comes from a long line of traditional manufacturing in that we've been doing other methods of manufacturing much longer in 3D printing. We've done casting, molding, machining, joining, and all of these things have worked great for their specific applications. And 3D printing came about because we needed something that was like CNC routers, but instead of carving into a block of wood, we need to be able to make something from relatively nothing. So I have here with me filament of spool. Excuse me, a spool of filament. And from this, you'll see that there is like a strand like plastic, kind of like a spool of yarn almost, except for this is PLA. We'll go over what that stands for later. And that is pulled through the hot end at about 230 degrees Celsius, and it melts onto the bed as it's deposited, layer by layer by layer, until you have something that looks like this. This is a very simple print of a cube, but it started from the bottom and it had to do layer by layer by layer, making these indents in the side as it went until it got to the very top of the cube. 3D printing, it was unique because unlike CNC routers, instead of tearing away material and having all this scrap, you had built something from the material that you used, and maybe you had to tear some parts off for supports. Other than that, the waste cost was negligible, which people really liked. However, because of its unique economy of scale, it is still a very expensive procedure, at least industrially. For consumers, it's gotten a lot more cheaper because an individual by the name of Adrian Boyer came up with the idea of what if we only made the parts of the 3D printer that are sensitive to temperature metal, or the bed? What if we only made that metal and all of the parts that hold the filament, that hold the motors, the manual controls, even some parts of the chassis of the 3D printer? What if we made those just the 3D files that we printed? So instead of each 3D printer being made from a metal body, you would have 3D printed parts mixed in with the parts of the body that needed to be metal, which reduced the cost greatly. These parts were also shared online as 3D files. They were open source, which means anyone could download these files for their 3D printer and make modifications to them to fit their needs. This enabled hobbyists to even go so far as make their own 3D printers. When you make so many different modifications, it becomes its own beast. So, what are the 4 steps of 3D printing? This looks very elaborate, but we're going to start from square one. When 3D printing something, you need to have more than just an idea. You need to have more than just a photo of something. You need to have a computer generated 3D model of what you're trying to print. One of these can be made from scratch using 3D modeling software like Blender. It's open source 3D modeling software. One that we like to use here in the 3D printing lab is called Tinkercad, which is all online. You don't have to download anything, and it gives you pre-generated shapes that you can stretch and bend and flatten, and you can even join shapes to other shapes until you have something that looks like what this person has made here, which is like a rectangular object with holes in it. Once you have your 3D file, you need to kind of put it in a format that the computer understands. which is the same as if you were to save your Word document. You're saving that document in a format that the computer understands so you can access it later. The format that 3D printers really like, or rather, your computer and your 3D printer can agree on, is called an STL, or a standard tessellation language. This file contains the mesh data, or the collection of layers and faces that form the design. So if we go back to our little cube example, the STL file for this basically stored the computer code that had each layer filled in and where each layer wasn't filled in. Something as simple as that, just translated in a language the computer itself understands. Now, what do you do with this STL? Because it's still on the computer. You haven't printed anything yet. It's still in the digital cyberspace. So to get it from the computer to the real world, you need to translate it again. And this is done using a computer-assisted machining software, or a CAM. They're also referred to in 3D printing as slicers, because the process of converting an STL into machine language is called slicing. Um, so once you render it through the software and you've reviewed how the design is going to look before it's 3D printed, because really nice slicers, what they'll do is they'll even show you where the nozzle will travel as it goes through the printing process, and you can see exactly where supports are, which is what this the structure that is in this image here. It's called a brim support structure, where they print layers of filament around the block so that the edges don't curl up from cooling too fast. That's more secure to the bed as well. Once you've reviewed your model in the CAM software and you've converted it from an STL to a machine file, which is just a bare bones list of instructions that the 3D printer follows to create this shape, you then move on to the 3D printer, typically with the file on an SD card, or you can upload the file to a server that your 3D printer is connected to if you have a really nice one. Once that file's on the 3D printer, you go through the motions of calibrating the offset, cleaning the bed, the pre-print work, kind of setting the scene to make sure that there's no obstructions or anything that will get accidentally added to the 3D print simply because it was on the bed at the wrong place in the wrong time. Once your bed's clean and your file's revved up, you've got nothing left to do but print, which is the final step of 3D printing. So we're going to touch very lightly on consumer versus industrial, as this part gets a little droll, but it does exist for a reason. There is a spectrum here, and it starts with desktop 3D printers, which is what we have here in the 3D printing lab. We have 3D printers that are so small, we can just stick them on a countertop and use them like you would an inkjet printer. They are typically already assembled. They can also come in what's called a DIY, a do-it-yourself kit, where all the parts are disassembled and you put it together like a very expensive Lego kit. If you are a new owner of a 3D printer, I would definitely recommend getting into some kind of support community for 3D printing if it's your first time owning a DIY, or if you don't have that option available to you, getting one that's already assembled is always the safest choice. Then we move on to mid-range 3D printers, or the prosumer choice. We call ourselves consumers because we buy things and use them. We consume them. Prosumer just means the opposite of that, where you buy tools to be able to produce things. So if you have like a small locally owned business, let's say on Etsy, and your whole thing is that you 3D print, I don't know, pencil caps. You need there to be a way for you to quickly and efficiently manufacture these pencil caps using your 3D printer. And that's what these mid-range 3D printers are used for. They have larger beds, they have larger parts, and they're a lot more efficient at creating, you know, larger builds, more builds, uh, a full plate of the multiple items, the same print over and over and over. Essentially, this is kind of like the halfway point between just printing for goofs and gaffs and printing as a service, which is our next step. Industrial 3D printers do exactly that. They are large scale machines. We're talking they sit on the floor and they're about as tall as I am, which doesn't mean much. I'm not that tall, but and what these are used for is unconventional 3D printing methods, or mid-range printing at an even larger scale. So this typically implies that these 3D printers have parts or applications that are industry specific and not consumer friendly. These are more akin to the casting and molding machines that you might find in a factory. So, I said earlier that we'd talk just a bit about 3D printing and what kinds of 3D printing there are. And just to run through the list here real quick, we have actually six, fused deposition modeling printers here at Oak Hill Collaborative. Stereolithography is one of the earlier types of 3D printing, SLA, that uses resin and UV light. There's also selective laser sintering, SLS, jet technology, SLA/FDM, so it's kind of like a mix of the two. Metal 3D printing, which we'll talk about, and what you see happening in this picture here, which is bioprinting, or printing tissue material, which we'll also talk about here in a bit. So FDM is the style of printing that we use here in the makerspace. It is also arguably the simplest way to go about printing. It's toothpaste through a tube. It operates by extruding hot filaments in layers of faces. Models are typically measured by how many layers are stacked on top of each other. And this means that sometimes the more layers a model has, the longer it'll take to print. Now, some cases where this is not true is if you're printing a cone, obviously the higher you go on a cone, the less time those layers will take to print. But that's not always the case with like a boat, for example. Speeds will vary depending on which layer you're on. These prints typically have what's called perimeter walls. I think a great example I have is actually right here. This is an unfinished 3D print. It actually failed halfway through. But you can see here that there's a solid outer wall. That's the perimeter of the 3D print. And then there's a rectangular infill on the inside here so that it doesn't have to make a completely solid 3D print, which would not be cost effective. You would probably go through a roll of filament every time you go to print something of considerable size. You can also use other infill patterns. I had a cube somewhere that was halfway finished that are kind of like honeycomb shaped, rectangular, rectilinear, which I think is just like really long rectangular lines. All of these are different options that you can explore in your slicing software. Another thing about fused deposition modeling, given that they're printed from the bottom to the top, as we mentioned earlier, there's support material that needs to be printed for any angle going over 45 degrees. So if your model has a slant, oh, I have another wonderful example right here. So I think this is a boat, I'm not sure. If your model has a 45-degree slant, you may have to put supports under there so that the 3D model doesn't droop while it's printing. And then those supports are then removed after the print is finished using pliers. Fused deposition modeling also has like a wide range of materials that this method supports. Two that we use here are acrylonitrile butadiene styrene, which is ABS. There's polylactic acid, PLA, which is the most common, or at least I think it's the most common. There's nylon. You can also print in polycarbonate, and there are more. The list goes on, so I highly recommend kind of asking around in these support groups. If you have an idea for a project that you would like to 3D print, see what they recommend for the material. Do you need something that's flexible and bendy? Like, is it going to be something that you wear on your face? I know that 3D printing masks was a big thing recently because of the pandemic, and there were certain filaments that you couldn't 3D print masks with because if they bent, they would shatter when they break, and no one wants plastic shards in their mouth. So these kinds of decisions became very important when choosing the filament type. Two more notes about fused deposition modeling, and then I swear I'll shut up about it. It's not always waterproof. So this thing right here, although it looks like a boat, I'm not sure how well it'll float. The reasoning for that is because it's built from the bottom up, it's not sealed between the layers. It is fused, but that doesn't mean that it is 100% waterproof between those layers of filament. It's not always isotropic. As I mentioned earlier, this is how it looks on the inside. meaning that the surface area right here is going to be a lot more dense and harder to break than the inside. So if you had something that was long and bendy, it would be easier to snap it in half. So it's not as strong on all sides. Stereolithography, which is one of the earlier forms of 3D printing. It uses resin as its printing material and it uses UV light to harden that resin. Unlike FDM, it is waterproof and it's equally strong from all angles, so it is isotropic. There is a wide variety of both opaque and translucent resin materials that you can use to print from. Like you can make something as, hard to see through as this, or you can make something like that boat there where light can come through it, but you can't really see what's on the other side all too well. Some downsides to stereolithography or resin printing, because that's a mouthful, let's be real. It's very messy because resin is a liquid. It's not a solid filament. So you kind of have to pour resin into this pool that the printer will then pull from as it prints. Um, it's also very toxic because resin is carcinogenic. So you're going to want to wear gloves when handling the inside of the 3D printer and when handling anything that you print, assuming that it hasn't had its UV bath. Speaking of UV bath, everything that you print using the resin printer has to go through multiple layers of post processing where you throw it in alcohol, let it sit for a bit, put it in a UV tank, let it sit in there for a bit, and depending on what you're using the 3D print for, it may have even more steps of post processing after the print. All right, selective laser sintering. I like this one because it's a different take on 3D printing. Instead of fusing hot liquid plastic and just shooting it out onto the board or using light to harden resin, this uses a laser to heat up powder. Typically nylon, could also be metal. And this type of 3D printing actually doesn't require support material. The reason for this is because, well, like FDM, it starts from the very bottom layer. It shoots that powder in the pattern that that layer requires, hardening all the nylon that was hit with the laser and leaving the rest of the dust there. Rinse and repeat as you go up the layers. And as you finish, when you finish your 3D printed model, you can just kind of give it a good shake. And all the excess powder or the nylon that wasn't centered comes right off. So it has its own support material and there's no need for clippers to get it off. Now, if it's a very elaborate SLS print, you might want to get like a brush. Some people even use compressed air to just blow the excess off. I find this to be very efficient because typically when you 3D print something and you get those all those supports off, you throw the supports away, and that's not as cost effective as simply shaking the excess material off, gathering it in a pile, and reloading the printer with it. So you're going through less material each print. SLS is unique in that it can be thin and flexible, it can be thick and rigid. Some of the downsides to it, though, is that the prints they kind of have a gritty texture, kind of like sandstone. It can't, and the reasoning for this is because it's not as accurate as UV light hitting resin. There's going to be some grit after you absolutely bond these powder atoms at the atomic level. After you bond them together, there's going to be some unevenness. So I wouldn't use this to 3D print a D&D model, for example. The machines themselves are also very expensive. I would imagine any high-powered laser would be very expensive. So this would be probably more in the middle to upper industrial class 3D printing. And let's see what else we got here. Jet technology. Jet technology isn't unique on its own. It's more like a combination of other types of 3D printing. It can do SLA and FDM, or it can do FDM and FDM with the other ejected material being soluble. So what you would do here is you would use it to 3D print something in resin, or no, not resin. You would print it in like ABS, like a harder material, and then you would print the support material in something that is soluble, so that when the print is finished, you just put it in a solution that dissolves the supports pull it back out, and you have a finished model. As you can see in the picture here, some people use it for multicolor prints, which is really handy because normally when you're 3D printing something, it's all one color. Resin is the same, whatever the color of the resin is, that's the whole model. And if you want that to be multiple different colors, you're gonna have to bust out the nail polish or the acrylic paint. Here, you can just 3D print it the colors you want it to be. I have here that it's all the benefits of a resin printer with less of the drawbacks. However, it is more expensive than just buying an FDM and an SLA printer and then using them concurrently. But because of the added benefit of two nozzles being able to work together simultaneously. All right, let's talk metal 3D printing. This one's always fun because there's so many different ways to 3D print using metal, and selective laser melting is just sintering, but instead of nylon powder, we're using metal powder, and you can use that to create like prototype material for car parts, for example. Bound powder extrusion is similar to FDM printers, but instead of using plastic, it's metal powder that is stored in the nozzle, the print head, and it's heated up so hot that it comes out kind of like melted filament, kind of like melted plastic, and it's just toothpaste through a tube, but instead of plastic, it's metal. Binder jetting is similar to jet technology where you build the supports using, let's say, ceramic, for example, and you use the other nozzle to do bound powder extrusion where you're printing with metal powder. And then when the print is done, you just break the ceramic supports off and you've got your finished model. When it comes to 3D printing, some of the common materials that you'll see that are supported is stainless steel, titanium, and aluminum. There are other materials that you can metal 3D print with, but these are the ones that you're going to see or come across the most often. Finally, there's bioprinting, 3D printing with biomaterials. This one is the one that interests everyone because it is radically changing the medicinal industry. It is a new area of medical technology. How it works is it uses biomaterials such as collagen, gelatin, hyaluronan, I'm not even going to try that one, silk, alginate, and other materials that are bio-friendly, things that are okay to have in your body. It builds kind of like this scaffolding or this structure that it can inject the gel into, and inside this gel-like material there is cell-like material, kind of like stem cells in a way, that is then treated in post-processing to be able to replicate cells that we have in our body. This post-processing is very elaborate, sometimes even takes longer than the 3D print itself, because what we're doing is we're treating this material so that it can self-replicate within the body and start multiplying like real tissue. Now, we're just in the process of figuring out how the tissue level works. We're not quite at the level of building whole new organs using 3D printing, but just to see how much progress we've made in such a short amount of time tells me that we're going to get there here soon. So it's exciting stuff. Hands-on session. Unfortunately, I don't have a new camera and I don't have a way of showing you the hands-on session of 3D printing. I hope that being able to just kind of grab things that I have around me and show you them on camera has sufficed so far. As I said, stop by anytime. We'll show you how this stuff works. All right, Q&A discussion. This is the part where I go ahead and try to pull up the chat bar, see if there's any questions that came up while I was presenting. And for those of you who did tune in, thank you. This has been Introduction to 3D Printing. I'm used to having a live audience, but I'm also used to rambling, so this is okay. I think this is a great topic, and I'm glad that I was able to do it all over again. So let's see here. We have, oh, that was last Friday. Yeah, we started doing Introduction to PC classes. So if you know someone that needs to learn how to use their computer a little bit better, we have an introductory social, no, not introductory, I'm sorry. We have an intermediate social media for small business class next Monday at 4 p.m. held here at the Oak Hill Collaborative. And then the Monday after that, we're going to be teaching people Microsoft Word. So if either of these things interest you, get in touch with us. We'll get you signed up. And furthermore, as I mentioned earlier, there's my office line. If you need to give me a call, please call before 5 p.m. Otherwise, I'm not here. Or you can give me an email if you'd like a tour of the facilities and come down and play with our cool 3D printers. Other than that, that's all I've got for you today. Thank you for tuning in to the redo of Digital Inclusion Week, and you guys have a wonderful evening. Goodbye.